Hello. Welcome all the 12th warriors. Today is the time we do the last part of alternating current, and that's transformers. So all of this with me, Shreyas, your physics master teacher at Vedantu. Hello Anil Kumar, hello Archana. Welcome aboard. Good afternoon. This is Shreyas, your captain. You can call me Captain Shreyas. And if you want to know more about me, you can definitely follow me on my Instagram handle. And this series, this Pathfinder series, is for all the 12th standard students. And guys, today is a special lecture. Guess why? Today is the last lecture of term 1 syllabus. Yes, we are completely done with the term 1 syllabus. And if you want to get more updates and you want to follow all the important news, notifications, and also get the PDF of all the sessions, then please join the Telegram group link, which is there in the description box below. So if you want to see any of the past videos, all you need to do is on our channel, just go to the playlist. Okay, just go to the playlist over here and you will see JEE Physics. Everything is for free. Okay, it's just there. And you will see that, you have the one-shot revision series for 11th as well. And you will see many classes for one-shot revision coming in the next few weeks, because a lot of students have a lot of backlogs and you want to revise all the chapters. So all of this is going to come up over here. This is the 11th standard series, the nurture one, and you can see right from electrostatics, Gauss's law, current, electricity, capacitors, magnetism, and that magnetic sources, and EMI, and then alternating current. That's term 1 syllabus done, and we will begin with our term 2 syllabus as soon as the term 1 examination is about to be over. So if you want to join the crash batches, well, in Vedantu we do have crash batches, and if you want to get amazing marks, because I'm pretty sure you would have seen the results, be it in 12th boards, be it in ICSE, be it in CBSE, be it in JEE mains, everywhere there are Vedantu students. In fact, there are more than 900 students just in top 10,000 ranks in JEE mains. That's crazy. So there is a batch which is starting on Monday. Go ahead, check out the link in the description box below, guys, because that's where you will get all the information. And these courses start for as low as 3,000 rupees when you use the coupon code SHHPRO. Hello Unknown Krish, hello Balaji, hello Jitesh. Vedanta Tattva is very good, Jitesh. I'm so glad you are loving it. So Vedantu Tattva has 4 exercises with summary and all the things that you would need. Something like this, it looks like this. So this is the Vedantu Tattva material. It's got summary, it's got theory. It's amazing. Glad you are enjoying it. Please solve all the problems. For sure you will get amazing rank in JEE mains. You see it. Very good. Anil Kumar, yes, I had my lunch. I hope you too had your lunch. Anun Krish, yes, but I remember you. Thank you. Hi Aditya Yadav, welcome. Hi Naveen, good afternoon. Hi Russell. Hello, I'm very good, Archana, thank you. Hi Shivri. Consultancy, the next chapter for 11th is circular motion, bacha. Yep, it's circular motion. Okay, so let's begin and let's talk about what is a transformer. Well, if you're a very good student, right, then the moment I say transformer, this is what it should click. Yeah, you should first think about the movie Transformers. And if you haven't thought about the movie Transformers, and if you haven't watched the movie Transformers, go ahead and watch it. And that reminds me, tonight at 7:30, I'm going to conduct a special session for all the movies that a science student must watch. So even if you are a 2021, even if you are an 8th standard student, that session is must for you. So tonight at 7:30, that reminds me of that. Okay, my God, Jitesh has watched all the Transformer series. Very good. Yep, Anon Krish, I know it's school timing, so maybe I will be conducting a poll on when do you want the 12th standard classes to be very soon. So probably you can tell me over there. Now let me tell you what actually a transformer is. See, you might have seen these big devices outside a society or outside a mall or outside an industry. Those are basically transformers, and their job is to increase or decrease the voltage accordingly. Depends. Generally at a power station it increases the voltage. At a transformer which is just outside your house, that decreases the voltage. We'll talk about the types of transformers very soon. Now transformer basically works on the principle of mutual induction. What is mutual induction? Whenever there is a coil, and let's say the coil is carrying some current. what does a coil which carries current do? It creates magnetic field. That's right. Now, if some of this magnetic field goes into another coil, that another coil I am going to call it as the secondary coil. I am supplying electricity in this red coil, which I am calling it as primary. The primary coil creates magnetic field around it. Some of the magnetic field lines pass into the secondary coil. The moment they pass into the secondary coil, here is what happens. If this current changes the direction, once here, once there, once here, once there. So the magnetic field will also change the direction, once here, once there. And what happens when magnetic flux changes? What happens when the field lines change? We know by Faraday's law, there is electricity which is created. That's right. So the moment the flux changes, you will see electricity is created. And because the flux is reversing its direction, you will see the current which is created, which is induced by Faraday's law, will also keep on changing its direction. Once here, once there. So an alternating current which is supplied here is creating an alternating supply over there, and this is wireless transfer, wireless energy. Yes, there is no physical connection. Okay, you might think, what is the job of this gray color metallic sheet over here? I will talk about it, but as such, there is no physical, conducting path from this primary to the secondary coil. Is that clear, guys? Yes, that's induced EMF. Yes, Vidya. Good afternoon, Shweta. Welcome aboard. Now, the idea behind this is, see, when the current changes, magnetic field changes, flux changes, you want maximum energy to go there. That means you want maximum field lines to go there. That means you do not want the field lines to go somewhere outside. Now, how do you prevent the field lines to go from going outside and leaking it out to the atmosphere? You don't want the energy to go out. You want the energy to go completely inside the secondary coil. That's why this gray colored, the sheet, this is basically your iron core. What is it called? It is called as an iron core. What does that iron core do? That iron core will make sure that, see, iron core is made of magnetic material like iron. Okay, so that will attract the field lines. So these field lines which are trying to go away, it will pull it inside. So 99.9% of the field lines will go inside only. Hardly any field lines will get, deflected, or they will just leak out to the atmosphere. So 99% of the field lines will just go inside. So maximum energy transfer. That's why you use this core. I hope that makes sense. Now, so what is a transformer? It's nothing but a device which can change a voltage from low to high or high to low, okay, and it transfers electrical energy from one electrical circuit to another electrical circuit. So from this circuit to the other circuit. That's what it does, and it changes the voltage or the current as per our requirement. So if you give an AC voltage inside, then you will get an AC voltage outside. The energy gets transferred from the primary side to the secondary side. You will see the current which flows in the primary side is called as the primary current. The voltage which you apply over here is called as the primary voltage. The voltage which you get outside is secondary voltage. The current you get outside is the secondary voltage. And interesting thing, you need a coil, and a coil always has turns. The number of turns on the primary side is NP, number of turns. Number of turns on the secondary side is NS. These are the terms which you need to understand. This is something which you should know. Okay, now let's talk about the working principle. Like I just told you, it's based on Faraday's law. So guys, we just saw that all the field lines faithfully will go inside. There is hardly any leakage. So all the magnetic field lines will have to go like this, most of it. Now, here is the logic for getting the formula for the voltages. I'm just trying to get a formula between the voltages and these number of turns and all of that. The idea is, if you take any one turn here, and if you take any one single turn over here, the number of lines that will be passing in one turn and the number of lines that will be passing in one turn will be the same. See, understand the number of turns could be different, total. So these 3 lines, for example, might cut through these turns multiple times. But in every single turn, they will be same in number. The number of field lines will be same in number. So can I easily say the flux per turn is same for primary and secondary. That's very, very important. It's same for primary and secondary. On the primary side, what I can say, okay, so on the primary side, this is what I can say. The EMF which is created here, alright, this EMF will be the total rate of change of flux on the primary side. So EMF on the primary by Faraday's law, okay, it is nothing but going to be magnitude wise d phi primary by dt. This phi represents the total flux in the primary side, the total flux in the primary side. This total flux will be obviously, remember there are NP turns, so NP into the flux through each turn. So it will be NP into d phi 1 by dt. What is d phi 1 by dt? d phi 1 by dt is basically this, flux per turn. So flux per turn is nothing but phi 1. I hope this makes sense. Everybody clear? Yep. So very good, Venkata Krish, if you're ready. Very good. Proud to know that. Hi Rishikesh, welcome aboard. Now for the secondary circuit, here is what I can say. The EMF in the secondary will be magnitude wise d phi s by dt. What is phi s? Phi s is the total flux in the secondary. Total flux, keep that in mind. But what will be the total flux? Flux of 1, 2, 3, 4, n turns are there. So n times the flux of every one coil. So it will be nothing but ns into d phi 1 by dt. This phi 1 and phi 1 will be same for primary and secondary. That's the catch. And now you have got to the final answer now. So what we are going to do, we're going to divide this and this. And let's see what do we get. So once you divide them, what you're going to get, EP by ES will be NP by NS. It will be just NP by NS because d phi 1 by dt, d phi 1 by dt both have cancelled. So this is a very important relationship. Primary by secondary voltage is primary turns by secondary turns. As simple as that. Yep, Jitesh, I conducted paper 2 physics. Paper 2 physics was done yesterday. Please check out my session which was conducted at 7:30. You will see that. My session is there. Yep. I hope you can see that. Alright. So very, very important derivation. The last thing over here that you need to understand is for current. This is very important. Generally, there could be 3 kinds of losses, okay, in case of a transformer. So what kind of losses you can expect in a transformer? One is the flux leaks out. So the first one is flux leakage. Okay, so the flux itself gets leaked out. So, you know, you can see some of the lines, if they do not faithfully go inside, you will definitely see, some amount of, energy being lost into the surroundings. So that's one kind of loss which you need to minimize. Second kind of loss that you might get is basically eddy current. Okay, eddy current losses. Now what is eddy current? See, whenever magnetic field is produced in this iron core, then even currents are induced in this transformer's core as well. Do you understand that? When this magnetic field changes, by Faraday's law, current will be created even in this metallic part, and that might create some current inside this particular gray core that you are seeing. The moment there is current, what will happen? Current produces I squared R loss. Current square into R is heat. And where is that heat? It's just going to go out. So the transformer will become hot because of these losses in the core. So that is basically eddy current loss. Is that clear, my warriors? Let me know. Hello Ajay, welcome aboard. Can I crack JEE mains in January by learning from YouTube lecture? Yes, modern man, definitely you can. The third way the losses can occur is when this magnetic field goes inside this gray colored core, it gets magnetized. Once the field is here, it gets magnetized in that direction. Once the current reverses, the magnetic field reverses. Once the magnetic field reverses, the magnetization also reverses. Again the current changes direction, field changes direction, the magnetization will be in different direction. Every time the magnetization keeps changing, flipping the direction, because this is AC. That means there will be some loss in magnetization, demagnetization, magnetization, demagnetization. What kind of loss is that? That is called as hysteresis losses. Okay, so that is called as hysteresis losses. So these are the three losses that you encounter in a transformer. This is what happens in reality. Okay, this is the reality. In spite of these three losses, the technology is so advanced that today's transformers, the losses are so minimized. Most of the transformers have efficiency, okay, efficiency of nearly 99%. Even if you read H.C. Verma book, you will see that over there. Most of the transformers hardly have 1% loss because of flux, eddy current and hysteresis combined together. So hardly any energy gets wasted. Isn't that fascinating, guys? So you can assume this has almost 100% efficiency. So for an ideal transformer, there will be 100% efficiency. Now, if there is 100% efficiency, what does it mean? The power which is going in will be equal to the power which is going out. Now, what is the input power? Input power is input voltage into input current. And what is output power? It is output voltage, which is ES, into output current. Okay, let me just do this. So therefore, EP by ES will be IS by IP. Oh, but EP by ES is NP by NS. So therefore, I can just write this as IS by IP. So when will this happen? This second part, this will happen only in the case of ideal transformers. Otherwise, there will be some loss and we will solve a question based on the losses as well. Is that clear, my warriors? Let me know. And if you have forgotten to smash the like button down there, go ahead and do this right now as a small favor to me. And if you are new to the channel, do not forget to hit the subscribe button so that you get my regular classes for term 1 as well as revision as well as problem solving, and immediately we will start with term 2 after term 1 is over. All right. Okay. So Shivam Kumar, what is hysteresis? See, bacha, when you pass some magnetic field, okay, so there is magnetic field through some material, what will happen? It will get magnetized north-south, correct? Now if you reverse the magnetic field, then what will happen? Then the magnetization, let's say you reverse the magnetic field, then the magnetization will be reversed. Because you are passing AC current, what will happen, bacha? The field will keep on reversing. If the field keeps on reversing, magnetization will keep on reversing. So when you magnetize and demagnetize something, it consumes some energy. That is called as hysteresis loss. You would have probably studied that in magnetism, but if you have not studied it, it's okay. I'm explaining it to you over here, but you can watch my detailed class on magnetism over in the playlist. It's there in the playlist. I hope that is clear. Okay? Yeah. So making the coil will not cause loss. I'm not sure, Venkata, what you have written. Okay. So can you please tell me that when will we complete the physics syllabus? Pranish, this is the last lecture of physics syllabus. It's done. Term 1 syllabus is done already. You have more than 1 month now to prepare. Yeah. So it's done. Okay. I hope this is clear. So term 2 syllabus also I will complete it before February or something like that. Okay. Once we start in December, I'll quickly finish it before February, because I am expecting your JEE mains will happen only by March end. Trust me, it will not happen before that. Okay, it will not happen so early because everything has been shifted because of the pandemic. So the transformer, what are the important takeaways? It works on the principle of mutual induction. This current induces electricity in the secondary coil. So there are two coils, primary and the secondary coil, and there is also core of the transformer, which is generally made of iron, which is magnetic. The job of it is to prevent the flux loss. The coils will have high mutual induction. That means most of the field lines should go from one to the other. There should be negligible losses over there. And when you pass AC current through the primary coil, it creates varying magnetic flux, and that varying magnetic flux creates electricity by Faraday's law in the secondary coil. So that's the basic principle which I explained, and I also give you the formula for that. So the ratio of the the ratio of the turns, NS by NP, will be ES by EP. So voltages are in the same ratio as turns, but voltages and currents are inversely related. Be careful about that, and this is only true for 100% efficient transformer. But a real transformer will have three losses. What are those three losses? Flux loss, eddy current loss, and hysteresis loss. But in spite of that, you get transformer still 99% efficiency. Okay, so what are the different kinds of transformer? Let's see that. Hi Nikki, hello San Mazur Rahman, hello Muthuram, welcome aboard. Yep. Okay, now here is the logic. See, whenever you want to increase the voltage, let's say you want to increase the voltage, what will you do? If you want to increase the voltage, that means the turns on the secondary should be more. That is called as a step-up transformer. So it converts a low voltage to low voltage of high current into high voltage of low current. So it is obviously inversely related. Look at this, it converts low voltage into high voltage. So whenever you increase the voltage, current won't increase. Obviously, current and voltage will be inversely related because power should be constant. So if voltage increases, the current will reduce. That's what will happen. And in this kind of transformer, the secondary turns will be more than the primary turns, or you can say the secondary voltage will be more than the primary voltage. This is step up transformer, and remember, the primary current will reduce. Obviously, the opposite of that will be step down transformer. More turns in the primary, less turns in the secondary. This is the kind of transformer you usually see outside your houses, and in this case you convert high voltage into low voltage. So what will happen? The turns on the secondary is less, the voltage on the secondary is less, but the current in the primary will be more. Current in the secondary will be more. So that's what happens in case of a step down transformer. I hope this is clear, guys. Okay, chalo, let's move on. So where do you see a transformer? This is how a transformer looks like, not the one which I showed you before. That was the movie screenshot. So kids, this is how it looks like. So transformer, you might have seen this. How many of you have seen this? Please tell me. Please tell me you guys have seen this. I would be very scared if you have not seen this. Okay, thank God Nikki, you have seen this. Okay, so it transmits electrical energy over long distances through wires, and it is used to minimize the losses during the transformer. Yep. Now you'll be wondering, sir, why would you want to increase the voltage? How does it help? Okay, let me tell you. See, you are creating electricity. Let's say somewhere there is electricity being created. So if electricity is created, okay, and you want to transfer it from the power station, this is your power station, to your house. Obviously, these wires have resistance, and whenever there is resistance, there is I squared R loss. If the current is more, what will happen, guys? The current is more, obviously I square will be very large, and I squared R will be very large, and because of that the losses will be very large. So what do? You will try to reduce the current. Whose resistance is this? The wire's resistance. How do you reduce the current? By increasing the voltage. So over here, just before giving it to those wires and transmitting cables, you have a step up transformer. What will a step up transformer do? Increase the voltage, reduce the current. If the current reduces, I squared R loss will also reduce. But yes, this voltage is very large. It's a step up voltage. So voltage has increased, current over here has obviously reduced. I don't want this large voltage. So just before it reaches your house, what will you do? You will reduce the voltage by step down transformer, and obviously the current is retrieved back. So very smartly, you have reduced the losses in the wires during the transmission. Yeah, I hope this is clear. It's helpful for converting high voltage to low voltage. Yes, Revagatan Kandan. Yep. Hello, mathematics boy. You're from Hyderabad. Welcome. Lot of Telugu people, lot of Tamil people, lot of people from Maharashtra, even from Kanyakumaris, Kerala, a lot of people from Jammu Kashmir. I've seen a lot of people from even Bihar, UP, Madhya Pradesh. I mean, people from everywhere, even people from Sri Lanka were here. So glad to see you guys here. So it is used to increase the voltage for step up in the generator side and step down in the household side. Okay, so that's what it is. So you should know these applications. Great, let's start solving some questions coming up on your screen. So very simple questions, guys. I'm pretty sure you will knock it. So one thing you have gained from attending today's class, there is a good chance there might be a question of transformers in JEE Mains or maybe advanced or maybe NEET or CBSE. And if that question comes, which is a very good chance, then you will remember this lecture, because for sure you will get those marks in your pocket, undoubtedly, guarantee. Okay, let's do this. The ratio of the number of turns in the primary to secondary coil is 5:2. The current through the primary is 3. Then the current through the final secondary load resistance is how much? That's the question. Come on, my warriors. Oh yes, surely Arslan Sheikh, definitely Bacha. I will definitely make it. Okay. Let's get going. Hi Muhammad Faisal, welcome. Good afternoon, good afternoon. So the number of turns is 5:2. Let's do this. So NP by NS, if you recollect, was IS by IP. It was inverse. Now the primary to secondary ratio is 5:2. This is 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 unknown because the current through the load resistance means basically IS is how much. So I do not know IS. And the current through the primary coil is 3. So IS will be 5 into 3, that's 15 divided by 2, which is 7.5 amperes. That means the option is A. How many of you got it? Perfecto, Shiv Kumar, mathematics boy. Oh, Mohammed, no problem. It's not C, it is A. Okay, be a little bit careful. Okay, let's get moving to the next question coming up on your screen. Okay, this will help you get even more confidence on transformer related questions. Yes, Nikki. Yes, Archana. Correcto. Perfecto. Let's get going, my warriors. 100 watt power is fed at 20 kilovolt in the primary coil of a transformer which has 80% efficiency. Be careful. The output voltage needed is 200 volts. Find the turns ratio, primary and the secondary current. Okay, let's just draw this so that we get an understanding and a feeling of this question. So I have my transformer over here, okay, and this is the primary, and let's say this is the secondary. Let's write in whatever we know. 100 watts. This is 100 watt power. Input voltage 20 kilovolt. So 20 into 10 to the power 3 volt. The primary current I do not know. Secondary current I do not know. Okay, what else is there? The output voltage needed is 200 volts. Okay, so this is 200 volts. And this is 80% efficiency. This is 80% efficient, or 80% is the efficiency of the transformer. Okay, so let's do this. I think I know the input and the output voltage. That means I can find the ratio of the turns, very simply put. So EP by ES will be NP by NS. So EP is nothing but 20 into 10 to the power 3. ES is nothing but 200 is equal to NP by NS. Therefore, NP by NS will be how much? This is 10 if you take it, borrow it from 10 to the power 3. 200 and 200 will cancel. Only 10 to the power 2 will be remaining. That is basically 100:1. So that's the first answer that we got. 100:1 is the ratio. Next answer, we can find out the primary and the secondary current very easily, because 100 watts is the input power and power is voltage into current. So can I not say 100 is 20 into 10 to the power 3 into the input current? As simple as that. Make sense? Okay. So what will be the input current? It will be 10 to the power 2, that's 100, and this is 2 into 10 to the power 4. Okay, so 10 square and 10 square goes. I'll be left with 10 to the power 2 here. So that's nothing but 1 by 200 amperes. 1 by 200 amperes, you can convert it into milliamperes if you may like. So 1000 divided by 200 milliamperes. So therefore the input current will be how much, guys? Yep, it will be 5 milliamperes. So that's the second answer that we got. Now many people will be thinking, sir, I know what to do now. IP I know, turns ratio I know, I can find out IS. So if you do this, NP by NS is equal to IS by IP, you will get a wrong answer and you will get negative marks. But since you guys are attending my class today and you kids know that yeah, there is a catch over here, this is only applicable when it is 100% efficient, but this is 80% efficient. So you definitely cannot use this formula. This is invalid, very, very important. Okay, so you cannot use this. So what's the other alternative? Well, use brains. That's it. It's very easy. See, 100 watts is input. It's 80% efficient. That means on the output side, what will be the power? It will be 80 watts because of this 80% efficiency. 20%, that is 20 watts, is lost. Great. And what is power? Power is voltage into current. Just use that. So 80 is 200 into the secondary current. That's it. So therefore, IS will be 80 divided by 200, 0 goes. This will be 4 divided by 4. So it will be 2 divided by 4. This will be 5. So 2 by 5 amperes. Yep. I hope this is clear. So I is nothing but 2 by 5 amperes, which is again like 0.4. If you want to write it as 0.4, might as well write it like that, 0.4 amperes. So that's the final answer. Okay, so guys, do not use this because the efficiency is not 100%. Clear? Hello, Athli Srinu, welcome aboard. Correcto, Regatan Kandan, welcome. Very good. Thank you, mathematics boy. All right. So now that's it, guys. That's all that is there in our transformers. So we got all the answers. I have left a question for you guys to solve at home. That's it. Trust me, once you solve this question and you post up the answers in the comment section below, you'll feel very confident, and I will leave the answers as well as the solution in our Telegram channel. Okay. Oh, by the way, there is a surprise in case you do not know about this. I'm conducting problem solving sessions for term 1 questions for JEE NEET students. So that started on 20th of September. It ended on 1st of October. The recordings are available. And the next course, actually, I don't have the slide for that, but let me tell you, it started on 4th of October till 15th of October for magnetism. This is on magnetism and EMI and AC. All these 3 chapters together. Okay, problem solving sessions very similar to that. Just replace this 20th September by 4th of October, and the last date, it's 15th of October. So that's magnetism and EMI. Those are live classes. Those are absolutely for free of cost for all of you. So guys, if you are already a pro member, it will be seen and you can just enroll into the course as well. Now, if you want to get these memberships, definitely you would want all the micro courses as well as the crash courses and the long-term batches, along with the tests, assignments, the teachers, the strategy sessions, all of this. So where do you find all of this? A lot of you have this question. All you need to do is, once you are watching our videos, let's say right now you are on this home page, okay, just go down a bit. You will see there is CBSE term 1 and 2. There is a CBSE course, okay. This is for term 1 and term 2 together. Both the courses are running and you have 3 options. I'll explain what that is. Similarly, you have dropper batch related sessions. All right, over here, that's the link for dropper batch. You'll see class 12th JEE. That's this one. If you click on this, you will again see this is inclusive of all the chapters, including revision, mock test, test, assignments. So live classes, test series, assignments, notes, everything, doubt solving. Now, if you want doubt solving on the mobile app, that's when you go for the classic version. And if you want mentorship, then you go for the plus version. Now, what does doubt solving mean? That means in our app, you can chat with our doubt experts and get your doubts clarified then and there itself from morning till night. Unlimited number of doubts. Yes. So you don't have to run around, Google search and get confused. And in the personal mentorship, you also get, strategies, you will get guidance and all the personal features that you would expect from somebody who actually cares for you. And this is coupled with, you know, all the classes and all of that. And you can see the prices for entirely 1 year. For the light version, it's 35,999 rupees. You get 10% off by my coupon code SHHPRO. And you have an option for trying it out for 1 month. So I would say at least try it out for 1 month and see how it works. And the same thing is also available for you guys to try it out for 1 month. And if you think that, no sir, I want this for the entire year, no problem. You also have the EMI option, which is again very cheap, 3,450 per month. So all the options are available for all of you. So I would really expect all my lovely warriors to be seen in the pro subscription very soon, because these prices are unheard of. You will never get these prices in an offline institute. Take care. Bye bye. Bye bye Nikki. Bye bye Hima. Bye bye Pratik. Take care. Have a great time. So Archana, that's the micro course called as Magnetism, EMI and AC Problem Solving by Shreyas sir. It's a part of the pro subscription. Okay, so when you are a pro member, this micro course is for free. So in the add more options, add courses, you can just go there, search for my course and you will get it. But if you still are not able to find it, leave a comment, Archana. I will ping you the link and the name and everything so that you will be able to get it. Okay, fine bacha. Take care. Have a great time. See you again tonight at 7:30. This was Shreyas here, your physics master teacher, and I was going live from Bangalore. Hasta la vista.